Hello students, in this video I am going to explain about complex numbers. In earlier classes we have studied about real numbers. Real numbers includes rational, irrational numbers. Rational, irrational. Rational numbers and irrational numbers both commonly called as real numbers. Along with real numbers, there exists another type of numbers called non-real numbers. Non-real numbers or complex numbers. These non-real numbers are also called as complex numbers or imaginary numbers also. Sometimes they are called as imaginary numbers. First of all, we will see how these complex numbers were introduced. Let's take an example. X square minus 9 equals to 0. Suppose you have given a quadratic equation to be solved. So you know very well how to solve this quadratic equation. X square is equals to 9. X equals to, on removal of square from one hand, we are going to get plus or minus square root on the other hand. Already we have 9. So plus or minus root 9 is 3. So we got two values for x. One is plus 3 and the second one is minus 3. Both are real numbers. But suppose if you take another quadratic equation, that is x square plus 9 equals to 0, how will you solve? X square is equals to minus 9, x is equals to plus or minus root over minus 9. Can you write root over minus 9 as a 3? No, because 3 square cannot give you minus 9. So we already know that negative real number under the square root is not a real number. So negative real number, whenever you have negative real number under the square root, we used to write real solution does not exist. In earlier classes we used to write like that. But from now onwards, you must observe a new thing. A scientist named Yuva given solution for this kind of equations. So whenever you have negative real number under the square root, he has given solution by introducing iota, by introducing a symbol iota denoted by small I, iota in place of root over minus 1. He said to use in place of root over minus 1 iota. So what is the result if you use like this? Now we can find the solution of this equation. Plus or minus root over minus 9 can also be written as root 9 into root minus 1. X equals to plus or minus root 9 value 3. Root minus 1, according to him, root minus 1, we can replace it with iota. Now we got two values for x. One is plus 3 iota, second one is minus 3 iota. But both are not real numbers. So these are known as non-real numbers. So this equation has non-real solution. So in this way they introduced complex numbers or non-real numbers or imaginary numbers. Now let's go to the definition of complex number. A complex number can be defined as an ordered pair of real numbers. So already real numbers existed. So with the help of existed real numbers, now we can write complex numbers. So see the definition, an ordered pair of real numbers. Suppose A, B, if you take A, B as real numbers, then A comma B, ordered pair. If you list these two real numbers in an order, A comma B, then it would be a complex number. We can give number of examples. For example, A is equals to 2, B is equals to 5. 2 comma 5 is a complex number, we can say. Suppose A is equals to -1, B is equals to 6. This is also a complex number. Suppose A is equal to -3, B is equal to -1. This is also a complex number. A equal to 0, B equals to 5, or A equals to 6, B equals to 0. All these are various examples for complex numbers. Now we have another definition also for a complex number. The numbers which are in the form of A plus iota B are called complex numbers. So A plus iota B form. If you see 3 iota means it's in the form of A plus iota. If you see the symbol iota, so those kind of numbers are called as complex numbers. What is the address of B? A, B both are real numbers. So by taking different real numbers for A, B, we are going to get different complex numbers. What is the address of I? So as I said, iota. Iota is equals to root over -1. Do remember. So on squaring, you will get iota square is equals to -1. Very useful relation. So iota square, while solving problems, okay, you can use whenever you get iota square, that can be replaced with -1. Do remember. So we can give number of examples for this. Suppose A is equals to 2, B is equals to 5. 2 plus iota 5, or better to say 5 iota. It would be better. 2 plus 5 iota, -1 plus 3 iota, 1 minus 2 iota. Okay, so -3 iota. This is also in the form of A plus iota B. If you assume here 0, A equal to 0, so this would be in the form of A plus iota B. So the numbers which are in the form of A plus iota B are called complex numbers. And there are some points to be remembered. Set of complex numbers is denoted by capital C, as we use to represent the real number. The set of real numbers is denoted by capital R. In the same way, set of complex numbers is denoted by capital C. In general, complex numbers are denoted by Z, Z1, Z2. So in problems, while solving problems, if you want to assume any complex number, that can be assumed as something Z. Suppose x comma y is a complex number. If you want to give name for it, you can give it as Z. Or if you want to assume another complex number, Z1, x1 comma y1, like this. We use Z, Z1, Z2 to represent complex numbers. Next, A comma B, A plus iota B. Both are equal. A comma B, A plus iota B. Okay. So forms are different, but both represent same complex number. Okay. Next, set of real numbers is always the subset of complex numbers. So how? For example, we'll take an example, 3 comma 0 in the form of A comma B. So this is a complex number. Suppose if you write in the form of A plus iota B, 3 plus iota into 0. So on simplification you will get 3. What do you know about 3? 3 is a real number. So it's a real number as well as a complex number. So each and every real number can be expressed in the form of A plus iota B. For example, root 2. Root 2 is a real number. It's an irrational number. So root 2 is a real number. Root 2 can also be expressed in the form of root 2 plus iota into 0. A plus iota B. So this is a real as well as complex. So I can say that every real number is a complex number. That's why set of real numbers is always subset of complex numbers.